Dear friends, right now this is actually October-November 2023. You can see here paper 4 variant 1 mean this is structured question. And right now we are going to solve the last 3 questions of this year. And I'm starting with question number 8. Wherever anybody is having a difficulty, you will be asking me without any hesitation and feel free. Either I'm on the same question or even I have moved ahead in the next question or the next part, whatever, don't worry at all. Now, a cylinder is made of modeling clay. The modeling clay is an electrical conductor. So electrical conductor mean it lets the current to pass through it easily. That is the meaning of this electrical conductor. Figure 8.1 shows this cylinder and its diagram is shown. The length is mentioned and the cross-sectional area is mentioned. There is it. Okay, and modeling clay, even I know when I'm performing the experiments with my students in grade 11 physics, Cambridge AS physics, which is, there is one paper 3, which is totally of practical exam of 40 marks. So very commonly, the modeling clay is the part of the apparatus, in part of the instruments or the part of the apparatus, because with the help of modeling clay, we can make different shapes according to the requirements. Like we can get a cylinder, we can get a particular dimension cylinder, we can get particular dimension cube, and like this. So this is some very useful resource for the practical exam point of view. Anyhow, so the cylinder is connected into this circuit. See, there is a circuit, and if you see this circuit, the same cylinder, this one is put over here. So this is the circuit in front of us. There is a battery. We will not say it a cell, this is a battery. And battery is always providing DC. Battery is always providing what? DC, direct current. There is a fixed resistor P, and then there is this cylinder of modeling clay. So I will be using capital M for modeling clay and P for this, and even 9 volt is for battery, something like that. But no, see, this is a series circuit. This is what? This is a series circuit. Okay. Now, my dear friends, 3 very important features of series circuit. I'm writing here. We need to know them and revise them very well. Series circuit. Number 1, I'm not writing all, but I'm saying all. Current is same. Current is same through each component. Like if we are told that current through this battery, I'm just assuming current through this battery, which will be the total current also, that is 2 amperes. Then current through this resistor P will be 2 amperes. Current through this modeling clay will also be 2 ampere for these given. So in series circuit, current stays the same through each component in series for the given resistances. This is the first point. Like we can say IB, current in the battery, is equal to IP, current in the resistor P, and that is equal to IMC. I mean MC for modeling clay. So current will be same through each and every component. And when you will say current, so you have to say through. When you will say potential difference, you will say across. This is the first point. And second point, which we need to know, that is, dear friends, see that this one, I can write V total. That is also the EMF of the battery. Here, the potential difference across this resistor, I will call it VP. And one thing, be very careful. See, I wrote V small. No. For voltage, always V capital. Then voltage across modeling clay, we can put it VM. No, my dear sons and daughters, here in the lesson, remember, V total is equal to Vp plus Vm. So total voltage is actually equal to the sum of the voltages. This is second point. And the third point, there are many more, but just most important I'm writing. The third point, that total resistance R total will be equal to R P plus Rm in this scenario. So in these three properties are there which you have to memorize all the time in series circuit. Number one, current is same through each component in series circuit for given resistances. Then total potential, total EMF of the battery or the total voltage will be equal to sum of the potential differences across the components which are connected in series. What do I mean by saying that? Total voltage in the battery is 9 volt. So V total is equal to Vp, voltage across, potential difference across resistor P, plus the potential difference across the resistor modeling clay, Vm. So even in notes in books you will find it will be written V total or EMF is equal to V1 plus V2 plus V3 plus so on, whatever the number of components connected in series. Then total resistance of the circuit in series or total resistance in series circuit is simply the sum of the resistances, of all the components which are connected in series. Then also something more, Ohm's law we can apply all the time, V is equal to IR, that is there. But also one thing more, as there is only one path for the flow of current, so if any one of the component is Harban, is not working, is disconnected, all the circuit will be disconnected, there will be no flow of current if any one component is not working. So these are basically 5 major properties of resistors in series. We will stick to right now as it is a series circuit, so series. I will sort out after this paper, I will discuss with you some question which is with the resistors or components in parallel, and we will discuss those parameters also today. Okay, now let's continue the question. Now, my dear friends, V total is given. The resistance of this P is also given. How much is that? That is equal to 4 ohms. Current in P, okay, by the way, current in P that is told equal to 1.5 amperes. I will not write current in P. It is everywhere 1.5 ampere because they are connected in series. And I told you while explanations that why this current is staying same. If you remember, if you will check chapter number 19 of our syllabus where we were discussing potential divider, and after series circuit, I have proved in front of you even the resistance is like. You may be thinking, no sir, resistor P may be greater resistance and a modeling clay small resistance. How the current can be same? Because current I is equal to V over R. So if this P has greater resistance, then the potential difference across it will also be greater, such that V over R is 1.5. Similarly, if if the resistance Vm is smaller, Rm is smaller, resistance of modeling clay is smaller, so the potential difference across it will also be smaller, such that still the current through it is same. I will just write, then I will rub. But wait a minute, what I'm going to write? I will see current is 1.5 ampere, resistance is 4. You know, I guarantee you now current IP that will be equal to Vp over Rp. Okay. Now let me tell you that Vp here that will be equal to 6. Rp is how much? 4. So as you will simplify, answer will be equal to 1.5 amperes. Okay. You know, yesterday we calculated the resistance of this modeling clay. It came to be how much? It was 2 ohms. Now see, how the current can be 1.5 ampere also across VMC. Now IM, mean current in the modeling clay, that will be equal to Vm, voltage across modeling clay, over resistance of the modeling clay. So when I'm placing the values, dear friends, here it will be 3 volts. And here it will be 2 ohms. Just simplify again, you are getting what? 1.5 amperes. So what is the rule? How current is staying same? This is journal numerically I have done in front of you, and see everything is consistent. You may be thinking, sir, okay, current is same. Total voltage, my dear friends, was 9 volts. Now see, here is 6 and here is 3. 6 plus 3 is what? Because 6 plus 3, it should be 9, and it is coming 9. I'm sure that all of you are not sleeping. Everybody is awake and concentrating. I will I will keep it there so that you can understand why the current is staying same in parallel in series circuit, and why the potential difference is the sum of the potential differences, mean total voltage in a battery, EMF of the battery is equal to the sum of the potential differences across different components. So EMF of this battery was 9 volts. Now see, for this circuit to be consistent, for this current and resistance should be can be verified if the potential difference across P is 6 and potential difference across M is 3. So 6 plus 3 is equal to 9. So everything is consistent. We are not saying, or we are not talking something that is in air, that is having no base. There are always bases. So what is the clue? If somebody, if you have to write sometime in explanation question, that how the current can be same if one resistor is bigger, other resistor is smaller. So very easy. Now see here, if the resistance is 4 ohm, which is double than 2 ohm, so the potential difference across greater resistance is also greater, such that the ratio of V to R, V over R is equal to current, that is same. Here resistance is smaller, 2 ohm only, and shear of potential difference is also smaller. So current is still again same 1.5. Now see, 2 2s are 4. Resistance is doubled. 2 2s are 4. Mean Rm is 2, Rp is 4. So Rp is 2 times than Rm. See the Vp. Vp is also 2 times than Vm. See, 3 2s are 6. So by the same ratios, they are increasing or they are decreasing, such that the ratio of voltage to resistance, which is equal to current, V to R, voltage to resistance, which is equal to current, that stays the same. One thing. And I will put it on the group, okay? Don't worry about this. I will put this lesson on the group also, even on YouTube also. No problem. So if something you need to relook, rewatch, it's okay. It will be available. I'm not going to rub this. I will do it on some separate page. Okay, now let's start the question. Calculate the magnitude x of the charge that flows through P in 600 seconds. This is a recall memory, very simple, straightforward question. So let's start from the definition of current. I. Current is equal to rate of flow of charge. I is equal to Q over T. So from here, my dear friends, if I'm making charge as the subject of equation, it will become I times T. So current, we know that is a series circuit. It is same all the time in this circuit, for this circuit. So 1.5 times T, which is 600, and as we simplify, answer comes to be 900. And what is the unit of charge? That is coulomb. So 900 coulomb. Let me take the question. That is from, yes, moment. I will share that one also. Don't worry. I will share that one also. So inshallah, don't worry. Yesterday's recording will also be there. Now our story starts that I was explaining. Resistance of the modeling clay. Resistance of the modeling clay, my dear friends, let me write here something. Resistance of the modeling clay, Rm, will be equal to Vr over I. Current is same, so no need to write IR. If you want to write, you can even write IR. Okay. Now, but we don't have VR. How to get VR? We can get VR by sorry. I'm sleeping a little bit. No, it is not VR. It should be VM. Rm is equal to Vm over I. Okay. Now we need Vm. Vt is with us. If we can calculate Vp, easily we can calculate then Vm. How to get Vp? Very simple. See, by Ohm's law, my dear friends, by Ohm's law, V is equal to IR. But right now, VP we need. Current is staying same in series circuit times RP. Okay. So VP will be equal to, this V should not be smaller. I'm intentionally writing it small, then rubbing and writing it bigger, so that you should not do this mistake in exam that write it in a smaller font. It should mean smaller, not capital letter V. Small letter V will be considered wrong. You have to write voltage, its unit volt, even volume. All these three quantities, two quantities mean voltage and volume. They are denoted by capital letter V, and the unit of voltage, which is V, volt, that is also in capital letter V. Anyhow, so V is equal to I. Current is same throughout the circuit, 1.5, and see resistance of P, that is given how much? 4. And as I'm simplifying, dear friends, this is coming to be 6 volts. Now, this was first mark. We scored. Now we need to get Vm so that we can put it here and we can calculate the resistance. So for that purpose, what I'm going to do, same formula from series circuit, that V total EMF of the battery is equal to V across P, resistor P, plus V across modeling clay M. Now, V total is 9. VP we just calculated equal to 6. Easily we can calculate Vm now. So mean Vm for voltage across modeling clay. So 9 minus 6, that will be equal to how much? 3 volts. Now let's place the values. And here also this is a blunder from Mr. Sajjad. Don't write this way that M should be in subscript, not in level with V. So now placing the values here, this is 3 and current is same throughout the circuit because it is a series circuit. So that will be equal to how much? That will be equal to 2 ohms. Now please, everybody in the lesson, if there is any query, any difficulty, please feel free and you can ask me. Waiting for your response. Quickly. I have put it in one frame also, like this. I will be waiting for a minute or so. Okay. Now let's move forward. Let's move forward. Yes, my dear.
Does the modeling clay have a specific purpose or only for shaping?
Only for shaping also, and it is a conductor, easy to shape, and it is conducting.
So they won't ask me about the purpose.
No chance at all, yes, son. No chance at all. That what I have shared with you, that was from A level's point of view. Here, they just want to check your basic information, basic knowledge, your understanding about series circuit. Nothing else. You should consider the modeling clay here as simply a resistor, nothing else.
Okay.
Then is that clear?
Yes, thank you.
Welcome. There is one more question. Let me take that. Then, my dear friend, if you ask me, I don't know what is a natural clay. Natural clay mean, no, that will be difficult to shape, I think. And I'm not sure that is conductor or no. But if they will replace it, they will be just giving you all the data. Okay, so don't worry about that. Okay, now Zen, both Zens are asking questions. Good, nice to hear from you people that you are in the lesson. Good, and everybody is supposed to be 100% concentrating into the lesson. Now this question itself is 4 marks. Yesterday I did it, but I want to redo it. By self, yesterday we were not we were actually stuck at one point. Then I redo it and we did it, but let's repeat it again. The cylinder is removed now. That is the purpose from the circuit. The cylinder means the modeling clay cylinder is replaced with a new cylinder and made of the same modeling clay. So it means its resistivity or something. If before resistance was 2 ohm for that dimensions, now for the same dimensions, resistance will be 2 ohms. But if the dimensions are changed, when I'm saying dimensions, it means length, width, thickness, height, something like that, volume, these things, area of cross section. The new cylinder is twice the length. Now see, this is the change in dimension, twice the length, and has the cross section, half the cross sectional area of the first cylinder. Calculate the time that it now takes for a charge of magnitude x to flow through resistor P. Now, what will happen? That's what. But see, time it will take, charge of magnitude. One thing should be crystal clear in your mind, that we are going to calculate this answer by I is equal to Q over T. And we need time, so make time as the subject of equation. That will be equal to Q over I. And yesterday Zen told me, sir, Q is 900 over I. For calculation of I, we need to do everything now. Why I'm using the same charge? They said very clearly, take for the charge of magnitude x to flow through the resistor P, charge of magnitude x. Here it is, 900 coulomb. So we will be using the same charge. Now, current we need to find. We can find current because we have the resistances. We can find current only in case. Just a minute, my dear students. Okay, my dear friends. Now calculate the time that it takes for the charge. We need to calculate current. For current, we need to know R, because very simple, we know V is equal to IR. So if we are having total resistance, we can easily calculate what? Current, because total voltage is already there. Now, my dear, here we need to be a little bit more concentrating and focusing. Now see, we know resistance is directly proportional to length. For 2L, when the length is doubled, this implies that resistance will also be doubled. And here, first of all, what we are talking about? We are talking about resistance of the modeling clay, Rm. So, because modeling clay is reshaped, so 2 times 2, so it means because of length, resistance is doubled. It has become from 2 to 4. This is the resistance of the modeling clay, 2 ohms. Okay. Then resistance is inversely proportional to area of cross section. So for half the area, this implies that the resistance of the modeling clay will be again doubled. So it means 4 times 2. So this is equal to what? 8 ohms. Now, dear friends, because of the changes in dimensions, mean length and area of cross section, the resistance of the modeling clay is increased from 2 ohms to 8 ohms. And when I'm writing this equation, V is equal to IR, actually this is equal to V total is equal to IR total. Current will stay same because it is series. In series, current is staying what same? What will be the R total now? Wake up, everybody concentrate. R total will be equal to Rp, resistance of the resistor P, plus Rm. So my dear friends, when we are placing them, so Rp was 4, it is 4, but Rm has become 8. So total resistance of the circuit has become 12 ohms. Now, what will be I? I will be equal to V total over R total. So 9 over 12, that is 0.75 amperes. Now, when I'm placing here 0.75 amperes, I'm getting 1200 seconds the answer. So this is the whole scenario to solve this question step by step. Dear friends, question is in front of you and I'm writing here Rm initially, which we calculated, that was 2 ohms. Okay. So this modeling clay cylinder is replaced with a new cylinder which is made up of the same modeling clay, but length is doubled, area is half. On doubling the length and reducing the area to half, both are increasing the total resistance of the modeling clay, because resistance is directly proportional to length. First line, I'm talking about this line now. So when the length is doubled, resistance of the modeling clay will be doubled. So 2 times 2, 4 ohms. So resistance has been increased from 2 ohms to 4 ohms just because of increase in length by 2 times. Again, resistance is inversely proportional to area of cross section. Now area of cross section is reduced to half. Resistance will be doubled. So 2 times Rm, it means 4 times 2. Why 4? See, this is 4. 4 times 2, that is equal to 8 ohms. Now, this is the change in resistance of the modeling clay. We need to find the time for the 900 coulomb charge to flow through the resistor P. So, we need to know the current now. And for current, we need the total resistance in the circuit. So, R total will be equal to Rp, which is the resistance of resistor P plus resistance of modeling clay with new dimensions. So, 4 plus 8, that is equal to 12 ohms. Now I is equal to V total over R total, 9 over 12. So 0.75 amperes is the current. Just place it over there into the equation and we are getting 1200 seconds as the answer. And I'm sure no, even mashallah, all of you are with good potential. I know you all well. So even you can explain to your fellows now like a professor this question, inshallah. Okay, let's move forward and we will see now the remaining 2 questions. Please read this question quickly. Okay, dear friends, let's continue. Many household smoke alarms contain a sample of radioactive isotope americium 241 Am. Americium 241 is an isotope of an element americium that has the nuclear number 241. Nuclear number 241. Okay. Show that how the composition of the nucleus of americium 241 differs from that of a nucleus of americium 242. 241, 242. Nucleus of americium 241 differs. I'm writing their symbols, dear friends. AM mean americium 241 has one less neutron than americium 242. See, differs from nickel. So, isotope. Isotopes are the atoms of the same element with different number of neutrons and same number of protons. So, either americium 241 or it is 242, their number of protons will be same. So, I did not write they want how it differs. If they were asking there what is the similarity, I was going to write they are having the same number of protons. Now, here one is americium 241, other one is americium 242. So, what will be the difference? Number of neutrons will be different. And 241 has one less neutron than americium 242. Very simple, straightforward, but you have to concentrate and you have to understand it well to answer. Now, see the next one is an atom of different element has a nucleon number of 241. Now, state two differences between the composition of the nucleus of this atom and a nucleus of americium 241. Now, see the answer. Have different number of protons and have different number of neutrons. Now you may think, sir, what is this? How come? Before there were isotopes of americium 241 and 242. So they were having same number of protons but different number of neutrons. 242 is having one more neutron than 241, or americium 241 has one less neutron than americium 242. But here one is americium still, but there is another element, different element, that is having a nuclear number of 241. Now we are not given what, but I can explain it to you people. See, we have one isotope of carbon, that is 6C14. We also have nitrogen, 7N14. See, nuclear number for both of them are same, but they are two different element. So if I'm going to check how many protons are there in carbon, they are 6. How many protons are there in nitrogen? They are 7. How many neutrons are there in nitrogen? 14 minus 7, 7. How many neutrons are there in carbon? 14 minus 6, 8. Now see, number of protons, different. Number of neutrons, different. But their nuclear numbers are same. So if the nuclear numbers are same for two different elements, it means they will be having different number of protons as well as different number of neutrons. Now same thing happened here, dear friends. One is americium 241. But there is an other element whose nuclear number is also 241. Remember, for different elements, their nuclear numbers can be same, but their proton numbers are never same. Proton numbers are never same. Proton numbers are same only in case if you have isotopes of the same element. So I'm sure with the help of this example, you have understood what I have written here. So they have different number of protons, they have different number of neutrons, even they have same number of nucleons, or their nuclear number is same. Now come to the next, that is formula question. We have already practiced a lot. Americium-241 decays to an isotope of neptunium Np by alpha particle emission. So complete the equation for this decay. First of all, we can easily complete 2 alpha 4. Now 93 plus 2. Here it should be 95, because number of protons are consistent, or the number of charge number is consistent before and after the alpha decay. So 95 is equal to 93 plus 2, also 95. 241, so here minus 4, so 237. Now 237 plus 4, 241. No need to waste a lot of time. We have done already this question many times. Now one reason for using an isotope that emits alpha particles in a smoke detector is that alpha particles are more strongly ionizing than beta particles. Why alpha particles are more strongly ionizing than beta particles? The answer for this, yes, my dear friends, who will answer me? Please, can you explain it? This is very simple. Many times we people have discussed this, not only once. Beta particle is -1 and it is very light. Its mass is negligible. On the other hand, alpha particle has charge of +2, because 2 protons are there and it's very heavy. So I will say alpha particle it is more strongly ionizing. I will say alpha particle has greater charge than beta particle, and it is having greater kinetic energy as compared to beta particles. So these are the two most common answers. Even you can memorize it. That's very easy. Yes, Lana, you are right. Larger mass as well as larger charge. So that's what I'm going to write. So I'm sure you people will be feeling easy, not any difficulty to answer or understand it in exam even. But still, these are a bit tricky. You have to be very careful. Alpha particle, particles have more charge than beta particles. One point. Second point, alpha particles have greater kinetic energy than beta particles. 2 marks. Now come next. The isotope of neptunium, which is after the decay of alpha from americium-241, is produced by americium-241 is also radioactive, but the decay of isotope of neptunium produces an isotope of protactinium. So when neptunium decays by emitting an alpha particle, so it is converted to protactinium. No, they did not mention it alpha, but let me read it again. So decay of this isotope neptunium produces an isotope of protactinium, which decays by beta emission, and beta particles are more penetrating than alpha particle. Half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of this long life for the use and safe disposal of a household smoke alarm. You know, when it is mentioned that it is having a long half-life, so it means its activity initial activity is less. What does it mean by activity? Like if a material is 100 gram, radioactive material is 100 gram, just to explain it, and its half-life is 1 minute. So after 1 minute, 50 grams will be decayed. Or let me say the activity was 100 counts per second. After 1 minute, it will become 50 counts per second. After another minute, it will become 25. Now see, in first minute, activity was higher, 50 counts. Second minute, it is lowered. How much? 25, and so on. But if initial count rate is 100 and half-life is 2 million years, so what do you think? In the lifespan of Mr. Sajjad, like average life for a human being, let's suppose in Japanese, they have long, above maybe 80. On the average, let's suppose 75 years. So in 75 years of our life, if the smoke alarm is there in the room, how much will be the activity? It will be very less. So that's what I'm going to write, that activity is less, initial activity is less, or the emissions per second are less. So it is not hazardous to human beings. It's not harmful to the human beings. So very few emissions. Emissions mean emission of the radiations. Very few emissions per unit time. So smoke detectors are not harmful to humans. That's what can be the answer. Okay, let's move forward. The Milky Way is one of the many billions of galaxies. Each galaxy contains many billions of the stable stars. Stable star? A star is stable when nuclear fusion is going on, but which type of nuclear fusion is going on? Nuclear fusion of hydrogen into helium is going on. That is the stable phase of the life cycle of a star. The reason for that, because the inward force of gravity is balanced by the outward pressure force. So resultant force is zero, so it means equilibrium, it means the stability. So stable stars transfer energy into space by emitting electromagnetic radiations from their surfaces. Like even sun is emitting energy or transferring energy into the space, which is also reaching to the earth in the form of ultraviolet, visible light, and infrared. And I have set them in the order of increasing magnitude. Like ultraviolet, the minimum radiations which we are receiving on the earth out of these three. Visible light, number 2, and maximum amount of radiations, electromagnetic radiations, which we are getting from the sun on the surface of earth or in the atmosphere of earth, that is infrared. And very common MCQ, very common paper 4 question, or not mean it is being repeated nowadays. They may ask you name the components of electromagnetic spectrum that are reaching on earth, are reaching in the atmosphere of the earth from the sun. So the maximum, sometimes they are asking in order also. So maximum is infrared, the thermal energy. Number 2 is the visible light, and number 3 is ultraviolet radiations. Anyhow, so describe what happens in the core of a stable star. And very important, they did not say at the surface of the stable star. The nuclear fusion is going on in the core. The reason for that, the required temperature to fuse the nuclei is only available at the core. Like for the sun, it's the surface temperature hardly 5,000 degrees Celsius or 5,000 Kelvin, let me say, better to say. Maybe I'm saying more, 3 to 4,000. And the required temperature is in millions of degrees Celsius for nuclear fusion to be executed. And I think it is simple memorization, but I think 25 or 15 million degrees Celsius is the temperature in the core of the sun. So to release energy, that is eventually transferred into the space. that is eventually transferred into the space. 3 marks are there. So you know what is going on. I will say that nuclear fusion is taking place. What is happening in nuclear fusion? Hydrogen nuclei fuse. Even you can write join. Fuse together. Fuse together to form helium. Nucleus at very high temperature. Even you can write extremely high temperature. With the release of huge amount of energy. Huge amount of energy. Even you can write in the form of radiation, but that is more than enough. So this is simply the fusion which is taking place in the core of the stable star to provide it with energy. On the Earth, light from the distant galaxy. See, this whole question is simply a recall memory. Light from a distant galaxy is observed and analyzed by the astronomers. Is observed and analyzed by the astronomers. This information is used to determine the speed at which the galaxy is moving away from the Earth. Moving away from the Earth, redshifted. Describe how the observed light is different from when it was emitted. So the moment it was emitted from the galaxy, how it is different when it is observed on the Earth. So there will be a difference is that the wavelength will be increased and it will be redshifted. That's what 2 points, 2 marks. Redshift, Doppler's effect. So these things are very common in exam. So what we are observed wavelength will be larger, will be longer, and the light from the galaxy is redshifted. That's what we can say. The observed wavelength is longer, and so light from distant galaxy is redshifted. And this thing is a clue for the beginning of the life, the theory for the beginning of life, that is the Big Bang theory. Right now, what is observed that all the galaxies, all the stars are moving away from the Earth. I mean, they are moving from away, and if they are moving away, it means their wavelength, the light. How do we know that they are moving away? Because the like here I have written the observed wavelength is increased as compared to the emitted wavelength. So it means they are moving further apart from each other. It means the universe is expanding. And what is the Big Bang theory? It says that everything was started at one point. So if we just go back Now they are moving away. So it means in the past they were not that much further away from each other, and in further very past mean billions of years ago, of course they were very close and they were at one point. That is the singularity. So everything started from that single point. That's the Big Bang theory. So these things are supporting actually the Big Bang theory. Now state the quantity that the astronomers use to determine the speed at which the galaxy is moving away. So that is simply when the wavelength is increased. So simply you should write change in the wavelength. Now one thing very important and repeated one. Hubble's constant H naught is equal to 2.2 times 10 raised to power minus 18 per second. My dear friends, all of you are supposed to memorize this numerical value with unit. So numerical value of the Hubble's constant H capital naught is equal to 2.2 times 10 raised to power minus 18, and its unit is per second. Per second. Sometimes they are asking only unit. Now calculate the distance from the Earth of a galaxy that is moving away at a speed of this. So speed is given. We need to calculate distance. We are going to use here Hubble's law. That is V is equal to H naught D. And be very careful, dear friends. No capital V here, small v. It's not volume, it's not voltage, it's not volt. Speed. Speed is denoted by small letter v. So when we are making d as the subject of equation, it will be equal to v over h naught. V is given already 1.3 times 10 raised to the power of 7 over Hubble's constant, that is 2.2 times 10 raised to the power of minus 18. I have just placed the values. Now 1.3 times 10 raised to the power of 7 over 2.2 times 10 raised to the power of minus 18. And as it is simplified, 5.9 times 10 raised to power 24. 5.909. So 5.9, 1 even can be written, or we can write simply 5.9. So answer is 5.9 times 10 raised to the power of 24, and unit will be in meters. Now calculate an estimate for the age of the universe. Give your answer in years. No problem. Age of the universe, that is the reciprocal of Hubble's constant, T is equal to 1 over h naught. Only 2 marks. Write the formula for 1 mark and then 1 over 2.2 times 10 raised to power minus 18. And when I'm simplifying this, I'm getting the answer 1 over 2.2 times 10 raised to the power of minus 18. 4.545 times 10 raised to power 17. So 4.545. 545 times 10 raised to power 17, but it is in seconds. The answer is in what? Answer is in second. They won't answer in years, no problem. They won't answer in years, no problem. T will be equal to same number 4.545 times 10 raised to power 17 over each year has 365 days. Each day has 24 hours. Each hour has 60 minutes. Each minute has 60 seconds. So when I'm simplifying this, so answer over 365 times 24 times 60 times 60. I'm getting, my dear friends, 1.44 times 10 raised to power 10. So 1.44 times 10 raised to power 10 in terms of years. Okay. He can also ask you the answer in terms of billion years. Then you can write 14.4 times 10 raised to power 9 years. And 10 raised to power 9 mean 1 billion. So then it will become billion years. Okay, so be very careful. Billion years mean billion year is equal to it is equal to 10 raised to power 9 years. 1 billion year. Okay, this was simple, straightforward answer. Time, age of the universe is 1 over h naught. But sometimes this can be 3 marks, sometimes 4 marks. Then we cannot use directly t is equal to 1 over h naught. Then what to do? Just attentive for a moment. See, dear friends, v is equal to h naught d. If I'm making h naught as the subject of equation, it will become v over d. Okay, what is the basic equation? Speed is equal to distance over time. And if I'm making time as the, because age of the universe I'm talking, making time as the subject of equation, it will become d over v. Let it be equation 2. Where is 1? Let me say. See, time. This is time for age of the universe. If it is for 3 or more marks, then what to do? This way. Now, let's see, t is equal to d over v. Here it is v over d. So what to do? Flip it. Flip this equation. This will become 1 over h naught equal to d over v. So both sides we have flipped. Let this be, this to be equation 1. Now see, the right hand side of equation 1 and right hand side of equation 2, they are same. D over V, D over V. So it means the left hand side should also be same. My dear friends, T, which is the age of universe, it is equal to 1 over h naught. And that's what, because it was only 2 marks. And also we were supposed to give the answer in years. So no need to write this all detail. But if it is for 3 marks and you have to write the answer in seconds, no any further conversion, so then easily you can then it is okay, 2 marks. But if you have to answer it for 3 marks or sometime more, so then show the examiner first how did you get the time, which is 1 over h naught, and then get the answer or write the answer and put the values and get the answer. Please, my dear friends, if any one of you is having any question regarding this, feel free, you people can ask me now. Okay, that's great. Nice, there is no question, so stay blessed and thanks.